Hello, my name is Christina. So for this problem, we are asked to do a few different things. We are supposed to graph the function, estimate its domain and range, and then solve the domain and range algebraically. So we'll start by graphing it with a graphing utility. I'm going to turn on my utility, press the button y equals. Anytime we see f of x, that's interchangeable with y. So if I see f of x, that's the same thing as saying y equals whatever the function is. So I can go ahead and where it says y sub 1, I can punch in negative 2x squared plus 3. Then I can press the graph button, and it'll automatically make me a graph. Great, that was step 1. Number 2, we need to estimate the domain and range. Well, what does domain and what does range even mean? The domain means all possible x values. All possible x values. So if I look at the graph that I've just created on my graphing utility, I notice that the graph is going to extend on the bottom left and then again on the bottom right, which tells me that the domain of this function is all real numbers. And we have this cool looking symbol, which means all real numbers. All real numbers. And that is my domain. Now range, that's going to tell me all possible y values. I always remember which one's which because domain and range is alphabetical order. D comes before R, X comes before Y. That's how I remember which is which. So for the range, we're looking at what are all possible y values. Well, if I look on my graphing utility, it looks like the parabola does not go any higher than y equals 3. So I would estimate that my range is going to be all values will be all values where y is less than or equal to a positive 3. So I've graphed my function, I have estimated my domain and range, but then I'm also asked to solve it algebraically. So for this, I have two different methods. One is I might kind of think about, just from looking at the function, what the graph would look like. So again, this is if I don't have a graphing utility. So I notice that this function has what we call a parent function. The parent function here would be f of x equals x squared, which I will have memorized that that is a parabola. The basic shape for that parabola something like this. And then of course we have different translations and transformations. So this plus 3 would indicate I am taking that basic shape and moving it up 3 steps. This negative in front of my coefficient, in front of the x squared, indicates I'm going to be flipping my parabola over my x-axis. So that allows me to basically estimate that I could go up 3 and then flip that basic shape. So without having a graphing utility, I would be able to estimate that once again, my domain is going to be all real numbers. There are no limitations of x values that I could put into this function. It'll extend to negative infinity on the x-axis and to positive infinity. I can also see here that my range is indeed y is less than or equal to 3. From looking at that graph, I was able to sketch without a utility. Lastly, we might consider solving it algebraically by making a chart of different points. So when I do that, I make myself a chart, an x, y chart. Now there's a couple points that I like to always put in when I'm doing these problems, and those are just -1, 0, +1, and then I want to think creatively about what other points might make sense. So I'm going to plug these into my function and see what points I get. So if x is -1, I come up to my function. -1 times -1 is a +1. This becomes -2 plus 3, which is a +1. I'm going to do the same for 0. I plug 0 in up here. 0 squared is 0. This becomes 0 plus 3. I'll plug in 1. 1 times 1 is 1. Negative 2 times 1, negative 2 plus 3, 1. And then I can go and plot where these points would go. We've got negative 1, 1, 0, 3, 1, 1. And again, I can see my basic shape of that parabola. And once again, confirm that my domain is all possible x values is all real numbers, and my range is y is less than or equal to 3. And that is how you do this problem.